All right, so we'll start with notes 4, but you know how to do this first graphical page or graphical piece, so do those and then we'll go over them in a minute. So there's our answer choices for the first set. So that's old news. That's pretty easy stuff, I think. In fact, that's the statement of the next section there. One-sided limits are more obvious, aka easy, when a graph is provided. But when you want to find a one-sided limit from an equation, it can be a little trickier. So as always start with substitution. And if you get something nice, that's your answer. Like that's for all limits. Like just try to plug it in and see if it works. So I'm not even worried about the 2 plus thing yet. I just want to plug in 2. So 2 squared minus 4 is 0. 2 squared plus 4 is 8. 0 over 8, that's 0. There's nothing crazy about that one. We like those. I plug in 3 on the next one. 4 minus 3 is 1. 3 times 3 squared is 27, so 127. Again, there's nothing magic difficult hard about that. Pi over 3, so now we have to know our unit circle, but you guys know your unit circle. As soon as I can find people who are in attendance today. Tanner, how about the sine of pi over 3? Root 3 over 2. And just the cosine of pi over 3? 1/2 plus 1. So root 3 over 2 over 3 over 2. And you multiply the top and bottom by 2, or you can just kind of see that the bottom 2's cancel out. So root 3 over 3. Okay, so like that was easy. Just plug it in, get an answer, you're good. The trick is, we usually give you problems that don't work that way. Usually you get either a 0 in the bottom or an indeterminate form. And that's when things get a little bit weird. So let's plug in 3 on this one. We still start with substitution, and that's what leads us to the weirdness. 3 minus 5 over 3 minus 3. Negative 2 over 0. I can't divide by 0. Do you know what's going on at x equals 3? Like on the graph? There's a vertical asymptote because it wouldn't cancel. So vertical asymptote, I don't know which side is doing what, but it's either infinity or negative infinity. But like, which one? I mean, either one of them does not exist, but if I wanted to be specific, I don't know which one it is. So that's sort of the problem with the one-sided limits. Like it should be one or the other, but I don't know which. Okay, so this is where things get a little bit funky for some people. Plug in a slightly larger or smaller number. If you get not 0 in the top, but a 0 in the bottom, then you have a vertical asymptote. That's what we were just looking at. In fact, number 4 is the same example that we just did. We know there's a vertical asymptote at x equals 3, but on the right-hand side of 3, I don't know what's happening. I don't know if it's this way or that way. Like, I don't know if it's positive or negative infinity. So I want to figure out like which one it is. To do this, here comes the weird part. Plug in a slightly larger number if you're coming from the right, slightly smaller number if you're coming from the left. Maybe a different way to say that is to plug it in exactly as it looks. So we're going to plug in 3 plus. So 3 plus a little bit minus 5 over 3 plus a little bit minus 3. Now, if the answer is not 0, we don't care if it's a little more or a little less, because it's only about the zeros and the signs that we're worried about. So 3 minus 5 is negative 2, and I don't care if it's a little more than 2 or a little less than 2. That doesn't matter. But in the bottom, I do need to be concerned. 3 plus, a little more than 3 minus 3. It's close to 0, but is it a little more than 0, or is it a little less than 0? A little more. And again, if it helps to actually plug in something more than 0, 3.1, 3.01, yeah, you keep getting a number that's a little more than 0. So if I have negative 2, I'll write it out, divided by a small, very small, positive number, what is that headed toward? Negative infinity. So it's still substitution, but you're substituting the little plus minus thing, which is kind of weird. And so you just have to be careful and think about exactly what's happening here. So let's do the next one. Let's plug in 4 with a minus sign. The only time I'm worried about it, though, is if it goes to 0. So 4 minus 5, I don't care about the plus or minus, the left or right thing. 4 plus 2, don't care. 4 minus 4, now it matters. So a little less than 4 minus 4. So the top I've got negative 1 times 6. And in the bottom, 4 minus 4 is 0. But which 0 is it? That's a terrible way to phrase that question, because that's not exactly right. Am I a little less than 0 or a little more than 0? A little less, right? Because if I plugged in 3.9 or 3.99, then I'm a little less than 0. So I've got negative 6 divided by something a little less than 0. What am I headed toward? Positive infinity. All right, 6 works the same way, so you try 6. We'll see if we get the same thing. It's super easy till you get down to 2 minus a little more than 2. So 2 minus 2 is 0, but 2 minus a little more than 2 is a little less than 0. So 18 divided by a little less than 0 would be negative infinity. So a little bit weird, this idea of plugging in 4 plus or 3 minus. But it's not hard to do. Number 7, I don't even know if you like how number 7 is presented. For simple functions, you can sketch a graph. So if you know what 1 over x looks like, then rather than plugging in, you could do a graph and know that 0 from the left is headed to negative infinity. But is that easier than just doing 1 divided by 0 from the left is equal to negative infinity? So you got options. Like if you know what the graph looks like, then you can do it graphically. But if it's a simple plug in, maybe it's easier to plug it in and not even worry about the graph. Occasionally, you can do this and still get an indeterminate form. So 0 over 0, infinity over infinity. If that happens, like it's the same rules. If indeterminate, then use our algebra tricks. So this is what the quiz was on Thursday. Like working on making sure you could do all those algebra tricks. So it's the same thing. Like if you get 0 over 0, do your algebra tricks, and then just like on Thursday, substitute again. And maybe it's with 0 plus or 2 minus or whatever. So we can sort of layer these lessons together. You do your algebra trick and then do the one-sided limits. All right, lastly, for limits when x is going to infinity, so when x is getting really, really big, you only need to consider the highest degree term in the numerator, the highest degree term in the denominator. Because when x gets really big, if I'm plugging in 80 gazillion, and I've got 4 times 80 gazillion cubed, well, the 19 doesn't really matter, and the x doesn't really matter. And even though 80 gazillion squared is big, it's nowhere near as big as 80 gazillion cubed. So you pick off the highest, or the highest degree term in the top and the bottom. Because when x gets really big, those are the only terms that are really going to matter. 4x cubed over 5x cubed, well, that's just 4/5. That was an easy one. Number 9. Sometimes we try to get tricky and don't put it in standard form, so be careful. Make sure you look at all the terms. Don't assume the first term is the biggest term. So negative 2x to the 5th over 7x cubed. That would reduce to negative 2x squared over 7. So as x gets really, really big, again, you officially can't plug in infinity because infinity is not a number, but that's kind of what you're doing, mentally anyway. What happens if you plug in infinity? What does this become? What'd you say?
Oh, wait, no, negative.
There you go. Negative infinity. So the infinity squared, that blows up, but the negative on the front of that makes it negative infinity. And then the last one, again, be careful. Make sure you grab the highest degree term from the top, the highest degree term from the bottom, because at infinity, that's all that will matter. And as x gets really, 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 really big, 1 divided by 7x. Be careful how you phrase that. 1 over 7x doesn't ever equal 0, but the limit means what are we getting close to? We're getting closer and closer to 0. We did that last semester, and there's a cute little saying that goes with it. Top no, careful, they're out of order, so if you can put them on there. Top no, bottom O, equal co. The only caution I would give with that is you only use that for limits as x goes to infinity. Like some people, they fall in love with top no, bottom O equal co, and you can tell that they use it for everything. You're like, wait a minute, that's like it's a nice saying and it's a great shortcut, but only for limits as x goes to infinity. So if you got limit as x goes to 3, don't do this top no, bottom O equal co business. For that reason, I'm always hesitant to give that, because then people fall in love with it and use it when they shouldn't. All right, your assignment is worksheet 4. The nice news is it's only 12 problems and they're relatively quick. And you have 30 minutes left. Okay, I should have made this due before you leave. I'm not. So if you've got other stuff you want to study, fine. But if you want to knock this out and not have any pre-cal over the weekend, strongly advised. Focus on baseball, soccer, whatever. Good luck, soccer. Good luck, baseball. Big time for soccer. Yes. When's the last time soccer made it this far? Do y'all have any idea?
20 years. How many games have y'all played, like including district? That's fair. It's the same way for baseball. If you ask me how many games you played.
14 district, I think, plus 3 playoff, plus like a bunch of pieces. A lot.
Like for baseball, we play each opponent in district. We play everybody twice. So, for playoffs, do y'all do one and done? Because I only say that because in baseball you have to do like a best of 3.
Well,
One and done.
Show up and make it happen.
Because baseball, you can lose the first one and then come back and win the next two.
You got some strategy because if the other guy has an ace, do you throw your ace or do you throw your scrub and hope you win the second two? Coach's decision on that. Usually he was not in that position. Somebody who's good enough to compete with everyone else's ace.
This year's been tough trying to find because we have a lot of good pitchers, but nobody's really coming out
Dominant.
or what it would have been recovered for engagement.
Yeah. Who's that?
Logan Harris.
He's injured?
He was overused. He was pitching too much, throwing too much. He was pitch something, or was just having a effort, so he's taking something.
Yeah, shut it down before it gets worse.
Plus, what really matters is playoffs later down the road.